Hello, Business 340. This is Dr. Ashbot. I'm here to go through the forecasting lecture with you. I have the spreadsheet open that's from your Moodle page, and I have the exponential smoothing forecasting, or the adjusted exponential smoothing forecasting from the PDF that's attached to Moodle also open on the bottom so we can see what the formulas are for completing this table. Before doing that, I have a little bit of a lecture to go through about a little more about forecasting. So let me pull up that tab. And the first question is most obvious is, what is a forecast? And there is a formal definition for that. It's a prediction of the future value of some variable. Okay. What kinds of things do we forecast? Well, it turns out we forecast a lot of stuff. We can forecast demand, and most of the time we're forecasting demand in business. But there's other people that forecast the price of commodities such as oil and gold. If you're a jeweler, the price of gold would be really important to you. If you're in the transportation logistics business, the price of oil is the number one cost for you. Sometimes it's the number of customers so that we can do staffing for a store, for instance. So there's lots of stuff that we forecast. And let's get into some forecast characteristics, shall we? The first characteristic or law of forecasting is forecasts are almost always wrong. Well, if they're almost always wrong, why do we forecast? Well, we need to get close. If we have a good forecast, we'll be close. I mean, think about other things that we forecast, like hurricanes. We want to know where it's coming and how strong it will be so we can evacuate the right people that will save lives and property. We know they're not 100% accurate, but if it's close, we can save lots of lives without having a lot of disruption for people. So forecasts are almost right, and that's true for the price of oil, the price of GDP. I mean, until a couple weeks ago, nobody was really forecasting a recession, and now we're well on our way. They're almost always wrong. We want to be close. And the whole idea of using forecasting is to get close, and good forecasting can be very profitable. Bad forecasting can be very disastrous for our organization. The next sort of law of forecasting is it's easier to forecast for groups of products than individual products. So, for instance, I can forecast the number of cars a lot easier than forecasting a particular model of car in a particular color and trim style. That's true because of aggregation effects, statistical aggregation effects. So what we try to do is we try to forecast for the grouping that makes sense. And the last sort of law of forecasting is they're more accurate for closer time periods. And we could see that with our hurricane forecasts. Typically 5 days out, there's a huge cone of uncertainty. But as we get closer into when it's going to hit, we're more certain about where the hurricane's going to come. This has other implications for supply chains. And right now, companies have supply chains that stretch the globe. It can be good to find cheap labor around the world. However, it reduces our forecast accuracy. And there's a cost to having bad forecasts. The costs are we either have way too much stuff that we have to discount, or we don't have enough stuff of things that are selling that are hot. And that leaves a lot of money on the table. If companies are better at forecasting, they would make a lot more money. As supply chains go more global, it goes against having accurate forecasts. There are other establishments that don't go overseas looking for cheap labor, and sometimes they're just as successful as the others because that forecast error, in knowing closer in what the forecast is, it's going to be more accurate, can save you a lot of money versus even the companies that are chasing cheap labor around the world. It's interesting. Companies are really finally starting to figure out that this is a really important deal, a really important consequence of forecasting. So, there are generally two types of forecasting methods. There is qualitative and quantitative. Qualitative forecasts are when we have absolutely no data. We have to just go on the fly. New products, fashion is historically uses qualitative forecasts. If we have numbers, so we have a product that's been out there a little while, we have demand numbers, well, I can use some quantitative forecast methods, and those tend to be a lot more accurate. We can only use quantitative methods if we have data. And finally, it's important to calculate your forecast accuracy versus your previous data. There are a lot of different forecasting methods. There's moving average, there's exponential smoothing, there's adjusted exponential smoothing, and what we're doing today is actually called double exponential smoothing. There's also linear regression, which we'll do also next week. There's weighted moving average, there's the winner's seasonality method. There's all sorts of different forecast methods. And so what we're going to do is use several of the forecasting methods on our data and then calculate our forecast accuracy and see which one's the best one. All right, that way we can select the method most likely to give us the best results. So now that we know a little bit more about forecasts, let's go back to our forecasting tab and use Excel to do some forecasts. Excel is an awesome tool to do forecasting. And when I do this lecture in person, I typically take an hour and do 10 forecasting methods, including all the forecast accuracy in that hour. And probably don't want to sit through a long lesson. I can post that on section 5 and 6. For those that are in Dr. Parker, Dr. Kahn's class, they can choose to do the longer lecture if they want. I have one recorded for a different class, but let me do the one for 340, the stuff that's been posted on the 340 website for the last couple years, actually. So we have double exponential smoothing, and we want to use Excel to do the forecast for us. So the first thing is our forecast including trend. That's what FIT stands for. So forecast including trend of t is f of t plus t of t. All right, so my f of t of 0 is going to be f of t is 0 plus t of 0. So that equation is going to be equals this one plus this one. Okay, that wasn't so hard to move into Excel. Now the next one is a little tougher. So now f of t has a bit of a formula. So what is it? It's going to be equals, so f of t, f of 1 is going to be fit of 0, which is this one, plus alpha, so we're going to use alpha, and I'm going to use this alpha over and over again. So I want to fix the row column, and I do that by doing the trick that we learned in earlier classes when we were doing our optimization models. So we do the F4 there, and then multiplied by this subtraction problem, A at t. So this is our actual demand, A at t minus 1. So we're going to use the A of 0 here, minus the FIT of 0, and there I go. So I put in this formula right here into this cell. It's going to be this cell plus alpha, and again I fixed the alpha, times the demand minus the forecast including trend. Okay. Next, I'm going to do the trend calculation. And the trend calculation is going to be the trend of 1 is going to be the trend of 0. plus delta. And in some books, it's beta here. Some books, it's delta. You really have to look when we do forecasting. It really depends on the textbook and what field of study it comes from. I've seen these equations done in lots of different ways. When I teach double exponential smoothing forecasting to the MBAs, these actually are the formulas, but I display them somewhat differently. Again, the format is different, but algebraically they're identical. Okay, and because I'm going to use delta for every period, I'm going to fix it. And then multiply, and this is where it's easy to screw it up. Okay, so it's going to be f of t. All right, but this is f of 1 here. This one. Minus fit of 0. Okay, so got to be careful here. Use the right one. So I'm using the row above for the t of t minus 1 and the f of t minus 1, and then I'm using the same row for the f of t. And if we do that, it will be right. Now, fun stuff. I can just copy these suckers down. Those will be wrong until I copy this guy down. And now I have my forecast. And I'll go ahead and put the yellow in here. Okay. And this is our forecast. So for period 7, I think I'm going to need 183.618. I'd round it up or down depending on how risk averse I was. So 184, that's probably a good number. Okay. Now, how good a forecast is this? Well, we find out how good a forecast is by doing our forecast accuracy. So I'm going to make a couple more columns here. Forecast accuracy and forecast accuracy in brackets. So my regular forecast accuracy is demand minus forecast. Demand minus forecast. And my other one is just the absolute value of my forecast error. Oops, sorry, forgot the equal sign. Equals ABS of my forecast. And then I'm going to copy these guys down to where I have both a demand and a forecast. So I can only do this through these periods. And then I'm going to take the average. And I'm going to copy that over. And what these values are, the average of forecast error is called mean forecast error. And the average of the absolute value of forecast error is called the mean absolute deviation. The mean forecast error, what does it tell me? It tells me on average, do I over forecast or under forecast, and how much? In this case, I over forecast by about 1.36 units. Negative is over forecasting, positive would be under forecasting. I'd like that to be 0, but I want to be as close to 0 as possible. But the mean forecast error is not actually the most important of these two. The more important is the mean absolute deviation, this number right here. We want this to be as low as possible. The mean absolute deviation will always be, well, it will be 0 only if the data matches the forecast for all the periods perfectly, or it will be some positive number. And what the mean absolute deviation gives you, it says, on average, I'm wrong by 2.44 units. It gives me the magnitude but not the direction. I'd like the forecast method with the lowest magnitude of error. Okay, why? The mean forecast error, I could be really wrong on the high side and then really wrong on the low side, and they'll cancel out to 0 and say, oh, look, I got a great forecast, where actually the forecast is terrible. The mean absolute deviation will show that forecast where I'm wrong high and wrong low, as being a very bad forecast. So what we want to do is select the forecast method that gives us the lowest mean absolute deviation. And for a forecast like this, double exponential smoothing, I have alpha and delta to vary, and I can change these. I can decide, okay, what if delta goes down to 0.1? Is that a better forecast? Okay, we saw the mean forecast error went down and the mean absolute deviation went down a little bit. What if it went up? Okay, in this case, the mean absolute deviation went down. So having a higher delta gave us a better forecast, even though the mean forecast error is a little bit more negative. What we try to do is find the alpha and delta that best match our current data. Now for exponential smoothing, typically the alpha is pretty low. It's between 0.2 and 0.3 for most applications. The delta is going to be higher if there's more of a trend in my data. It will be lower if there's less of a trend in our data. Who uses this? Car companies. Exponential smoothing is famous for car companies because they want to get close. They want to reduce the randomness because, forecasting methods, there will be a lot of randomness in the data and there'll be real trend in the data. And the object of forecasting is to find a method that doesn't react to the randomness but reacts to the trends. If you can find the best forecasting method that does that, that's what we're going to want to use. Because if you're always running a plant overtime and then laying people off, then running it overtime, laying people off because you're reacting to noise, that's no way to make money. So that's an intro to forecasting. I hope you learned something. I hope you saw how easy it is to do forecasting here. And good luck with your assignment.